Hello, my wonderful students. Today we are going to be looking at using exponents greater than 2. So we're going to have different base numbers that have exponents that are greater than 2. Please make sure before you start this lesson that you go to Canvas and you download and import the workbook for this lesson into Notability. The item that you need to download in Canvas is called Exponents, and then Exponents P2, so for Exponents page 2. So if you need to do that, go do that now. But we will begin our lesson. On here we can see that we have a tens block. What is the name of this block? Okay, and this represents the number 10. Okay, so here we have 10. 10 to the first power. We have another block here, which we like to refer to as what? Yes, the hundreds block. Here we can see that we have 10 blocks along the bottom, and then 10 rows of blocks. So we say that this is 10 times 10, okay, or 10 to the power of 2, 10 to the second power, or in this instance, 10 squared. This has a value of how many total blocks? 100. Okay. What could we say about the value of this block? Okay, how many total blocks are there? Okay, well we see we have 10 along the bottom, there's 10 rows, and it also extends 10 blocks back. How could we use exponents to represent this number? Okay, try looking for a pattern of what's happening here. Okay, we have 10 by 10 by 10. So our total number of blocks is 1,000. Okay, we have 10, 100, thousands block. So we can represent this as 10 to the third, okay, or 10 cubed. And you'll notice, okay, this is in the shape of a cube, this is in the shape of a square. So we have 10 squared, 10 cubed. 10 multiplied 1, 2, 3 times. Next up, I want you guys to look for any patterns that you notice. So take a second and see if you see any patterns. In this column here, in this pinkish purple column, what do we notice is happening in every row? So hopefully you noticed that 10 appears in every row as the base number. Each base number, 10, has an exponent. The exponent in this row is 0. Okay, so 10 to the 0 power, 10 to the first power, 10 to the second power, 10 to the third power, 10 to the fourth power, 10 to the fifth power, and then we jump to 10 to the ninth power, 10 to the seventh power, and 10 to the 11th. One thing that I think is a little peculiar is that they would put 5, 9, 7 instead of 5, 7, 9. Okay, now let's look and see if we can see a pattern, okay, between the number of tens that appear in this column and how it relates to what's going on with our exponent in this pinkish purple column, sorry. All right, hopefully you see that every time we're multiplying, okay, we're talking about the operation of multiplication. Okay, how many tens are in this column? 1. What is our exponent? 1. How many times are we multiplying 10 in this column? 1, 2. Exponent is 2. How many times are we multiplying 10 in this column? 1, 2, 3. 10 times 10 times 10. Okay, our exponent is 3. Now let's look here, and I want us to find a pattern with the number of zeros. Okay, when we're multiplying by 10 and we're raising it to a exponent, how does that relate to the number of zeros that we can put after this one digit? Okay, there's 1 0 here. Our exponent is 1. There are 2 zeros in 100. 1, 2. Our exponent is 2. There are 3 zeros in 1,000. 1, 2, 3. Our exponent is 3. We multiply 10 3 times to get 1,000. Let's work together to fill in the missing rows. All right, 10 to the 0, okay, is always 1. Any number raised to the 0th power is 1. 10 to the 4th, okay, how many times am I going to see 10 multiplied by itself? Okay, for 10 to the 3rd, we have 1, 2, 3. 10 to the 2nd, we have 1, 2. 10 to the 1st, we have 1. Okay. You got it, 4 times. 1, 2, 3, and 4. Okay, I could get out my calculator and type in 10 times 10 times 10 times 10, or I can keep working with this pattern, knowing that however many times I'm multiplying 10 or whatever my exponent is, that is how many zeros I have. So I have 10 to the 4th power. I'm going to have 4 zeros after that. 1, 2, 3, and 4. Please excuse my poor penmanship here. It's tricky recording on the computer screen. Wonderful. All right. Next up, 10 to the 5th. Yes, you guessed it. Okay, you used your understanding of the pattern to know that we should have 10 multiplied 5 times. 2, 3, 4, and 5. And how many zeros am I going to have after my 1 here, people? 10 to the 5th power, 10 multiplied 10 times, or 10 multiplied 5 times. Correct, 5 zeros. 1, 2, 3, 4, 5. Okay. I'm going to leave the rest. I think you guys are understanding a little bit of what is going on here. And the wonderful thing with powers of 10, it correlates directly to our number system. Okay, we have the tens place, we have the hundreds, then the thousands, 10,000s, 100,000s, and so on. All right. What do we notice about this table? What is different than this table? Biggest difference here is that our base number is 0 or 3. Okay? Base is 3, base is 3, base is 3. Okay? And we have exponents as well. Remember exponents, that's what we call these smaller numbers to the right of a base number. We have an exponent of 0. This is 3 to the 1st power, 3 to the 2nd, 3 to the 3rd, 3 to the 4th, 3 to the 5th, 3 to the 6th. How could we complete this table? Remember, any number to the 0 power is 1. Okay, again, 3 to the first power. Our exponent is 1. We have 3 one time. Our exponent is 2. We are multiplying 3 1, 2 times. Okay. Next up, we have 3 to the third power, or 3 cubed. 3 times 3 times 3. Okay, 3 times 3 is 9, times 3 is 27. Then we have 3 to the fourth power. How many times are we multiplying 3? 1, 2, 3, and 4. Do you guys see any other patterns here? Look what happens every time we go from one row to the next. Okay, I'm adding 2, but is that what happens from 3 to 9? Nope. Think of a different operation. I am multiplying by 3 every time. Okay, 1 times 3 is 3, times 3 is 9. 9 times 3 is 27. Okay, 27 times 3 is going to give me my next blank row of the table. 27 times 3 is 81. Which makes sense because we're just adding another power of 3. We're multiplying by 3 one more time. How many times am I going to multiply 3 if I am writing it to the 5th power? 3 to the 5th power. 1, 2, 3, 4, and 5. Again, 1, 2, how many times should I multiply 3 for this row? 6, correct. 3, 4, 5, and 6. One more missing spot to fill out, and I need to go 3 times 3 times 3 times 3 times 3, or take 81 times 3, because the value of these 3's multiplied 4 times is 81, and I need to multiply that by 3 one more time. I'm going to use our understanding of the generic rectangle to multiply 3 times 81. 3 times 80, 3 times 8 is 24, so 3 times 80 would be 240. 1 times 3 is 3. When I sum these together for the total area of that generic rectangle, I get 243. Now what I want you to do is go ahead and look at your canvas. Your notability, and look at the stepping in portion of that workbook that I sent you that you have in your notability. Wait for this to load. Okay. I think hopefully you can be able to do a screen split to look at this, so you can look at your workbook and notability, but you can also view this video. If not, just pause the video and go back to our journal and then back to the video. Okay. So let's work through these questions. For these two, on the left, we have squares, and each dimension is 10 times 10. Okay, what does 10 times 10 give us? 100. Good. Go ahead and fill that in your workbook. Okay. Go ahead and fill in 10 squared then. 10 is being multiplied 2 times. 10 to the second power or 10 squared. Notice where we get that term squared from, because a square has side lengths the same. When we find the area, we multiply that number by itself twice. So 10 squared, 10 to the second power is 100. However, when I add a new dimension and we have another length of 10, okay, we are multiplying it by one more power of 10. So we have 10 to the third power, or 10 times 10 times 10. We just need to simply add on another 0 to 100 here because we have 3 zeros and we have 1,000. 10 cubed. Okay, this figure is a cube, which many of you are familiar with. Five times 5 would be the area of this square here. We're multiplying 5 by itself 2 times. 5 times 5 gives us 25. So 5 squared, 25. Now when we take a cube that has all side lengths of 5, we call it 5 cubed, or 5 to the third power, 5 to the power of 3. 5 times 5 is, we know this is 25, so we need to multiply 25 by 5, which gives us 125. 5 cubed is then 125. While you guys are watching this, please do not just stare at the screen and listen. I want you thinking about the questions that I'm asking. Okay, how does each equation match its picture? Okay, it's the number of side lengths, okay, that figure has. Let's draw a picture to show 8 to the third power, 8 cubed. Okay, well, how many dimensions do we have? What is our exponent? 3. Okay, so if you look up here and think back to what did our power of 3 look like? We have a cube that has side lengths of, in this instance, 8. Again, my drawing skills are not too fancy, are they, guys? What does the exponent tell you? The exponent tells us how many times we need to multiply our base number. Remember, your base number in this case is 8, base is 5, base is 5, base is 10, base is 10. The exponent indicates the number of times that you multiply the base number. Anoki wrote 7 times 7 times 7 times 7 times 7 to expand 7 to the 5th. Let's write an expression to expand 3 to the 6th power, 3 to the power of 6. Okay, let's look back to what Anoki wrote. His base was 7. His exponent was 5. Okay, we see 7 here. That is the number that is being multiplied. Our exponent is 5. That's how many times we multiply it. 1, 2, 3, 4, 5. So how many times do I need to multiply my base number of 3? 6. 1, 2, that's a time sign, 3, 4, 5, 6. Alright guys, so this might have been a little bit rough. This is the first time I tried doing a lesson like this. Please go through and complete the rest of the workbook. Complete and show Miss Bleasy for a treat.